Lastly, we've got number 3 on the back of the lens and mirror review. This is a mirror. Because it's a mirror, instead of the light going through to the other side, it's going to bounce back this way. Instead of F and 2F, I've got F and what I call C, and that's the center, and it is also, it's equal to 2F. This would be an example of case number 1. And this is a concave shaped mirror. It's a converging mirror. Converging means bringing together. All right, so go ahead and draw what I got here. I'm using the top of my Christmas tree, that star, as my top of the object. And the first one goes from the top through C. Make sure you're going right through the center of C, and take into account the thickness of your pen. You want it to cross right through the center. Okay, and that one doesn't do any bending, no reflecting. Second one, pink one, goes parallel. I'm using my clear ruler to help me make sure that this is actually parallel here. Looks pretty good. Come all the way to this line, and then it's going to reflect through the focal point. Like that. And then the last one is going to go through the focal point first. And I want it to cross through the line, the same place that the pink line did. And when this hits the mirror, it's going to turn and reflect parallel. You can also measure from above so you can see the clear ruler. I'm lining up all these little lines. There you go. Where all 3 of them cross, this is where my image is going to be. Very tiny Christmas tree in there. Alright, so this is going to be real because it is on the correct side of the mirror, over here where the light actually is. Also, it's inverted, and it's smaller. Let's go ahead and do the math. I measure the focal length of this mirror. I got a focal length of 1.8. I'm going to say the distance to the object, 7.4. And the height of the object, 1.2. Okay, let's measure what I got for my diagram for the height and the distance to the image. It's like 2.4. So I got the distance to the image is 2.4. And the height of the image is going to be negative, because it's upside down, 0.4. Now let's check our math. Hopefully we're going to get numbers that are close to those answers. First equation, 1 over f equals 1 over di plus 1 over do. So 1 over f, which is 1.8, equals 1 over di plus 1 over do, which is 7.4. Set my calculator. 1 over 1.8 minus 1 over 7.4 Make sure you take the inverse of that answer, and DI is 2.38 centimeters. And it's pretty close to what we actually got measured over here. Okay, let's find the height. Here's my equation. HI over HO, 1.2, is equal to negative DI. Oh, sorry, I'm going to use this one that I found here with the math, with all the math stuff together. Over DO, which is 7.4. Cross multiply. Negative answer times 1.2 divided by 7.4. And I get negative 3.6. Negative 0.386. And the magnification, HI over HO. So HI over HO. The magnification is negative 0.32. All right, this looks great. DI here, and this is what I measured it, so those are nice and close. Because it's a positive DI, this is real. The HI, here and here, also very close. Because the HI is negative, that means it's inverted. And inverted and real will always go together. That also means that your DI and your HI won't have the same sign. You'll either have a positive and a negative, or a negative and a positive. And the magnification is less than 1, which means it is smaller. And the negative magnification means that it's inverted as well.